What is going on, guys? My name is Amos and welcome to yet another video. So in today's video, we're going to be talking about a lot of interesting things. So we basically don't have a specific title for this video because I'm going to throw at you guys a bunch of concepts. So first of all, the concept that we're going to talk about is the idea of equal sets. So whenever we've defined we've defined what subsets are and what it means for a certain set to be a subset of another. Well, this follows directly from the concept of subsets. So whenever we say that two sets are equal, let's say the set E is equal to the set, or just keep it in mind that E and F are sets. So anything that you see that is in capital letters is basically a set. All right. So if E is equal to F, then this is going to imply that E is a subset of F and F is a subset of E. So E est égal à F si et seulement si E est une partie de F et F est une partie de E. So whenever E is equal to F, we are trying to say that, okay, this is equivalent to saying that E is going to be a subset of F and F is also a subset of E. All right. So whenever E is included in the set F and F is included in the set E, a formal or a shorter way or a more concise way of saying that is that the set E is actually going to be equal to the set F. And dans le cas contraire, now if A is not equal to F, well, we basically have this. Dans le cas contraire, so otherwise we have that E is not equal to F. So when this is false, when this proposition is false, then E is not equal to F. Now here I can make a very important remark that you guys have to keep in mind. Well, if E is a subset of F, if E is a subset of F, and that if E is a subset of F and that E is not equal to F, we say that the inclusion of E in the set F is going to be strict. So the inclusion is going to be strict. So if E is a subset of F and E is not equal to F, meaning the other inclusion, the inclusion of F into E is not true. So if E is a subset of F and that E is not equal to F, we say that the inclusion of E into F is going to be strict. So we can read it, we can say E est strictement inclus dans F. So the inclusion of E into F is going to be what? Is going to be a strict inclusion. All right. The inclusion is going to be the inclusion is strict. So a more formal way of writing and this is that we can say E is going to be this is going to be that. So E est strictement inclus dans F. So E is strictly included in the set F, meaning we have that E is a subset of F and that E is not equal to F. Let me give you guys an example so that everything is well cemented. All right. Now let me just get rid of that. Let me have the three sets. So let X be in the set of natural numbers, and let's have X squared minus 3X plus 2 is equal to 0, and B be the set 1, 2, 3, and C be the set 1, 2, racine de 2. Alors, racine de 2. So I have these three sets. Now, based on what we've talked about, what relationship is between the set A and B and what relationship is between the set B and C? So if you look at the set A, we basically have a quadratic equation that we have to solve. Now, the discriminant of the quadratic equation x squared x à la puissance 2 moins 3x plus 2, the discriminant of this quadratic expression is going to be strictly positive, meaning this quadratic expression is going to be factorizable and we can find the roots of this quadratic expression. Now, if you evaluate this quadratic expression, you're going to have the roots. Now, the roots of this quadratic expression are going to be 1 and 2. So basically, we have that the set A is a subset of the set B and the set B is a subset of the set A. So now a more formal way of saying this is that A is going to be equal to what? A is going to be equal to B. So A is equal to B. That is simple. But if you look at the set B and C, it is easier to see that the set, it's easy to see that the set B is a subset of the set what? Is a subset of the set C, because every element of the set B is also an element of the set C. However, B is not equal to C because we have racine de 2, which is also in the set C. Therefore, the inclusion of B into the set C is going to be strict. So the relationship is going to be what? The relationship is going to be a strict inclusion. So we basically have B est strictement includant C. So that is all. That is all there is to know about equal sets. Well, another important concept that we're going to talk about is what we call ensemble de parties d'un ensemble. So what is this set that we're talking about? Now, let E be a set. Let E be a set. Now, let E be a set. Now, if A, all right, if A, B, C, D, and if A, B, C, D, if A, B, C, D are subsets of E, if A, B, C, and D are all subsets of E, well, the set that I'm talking about, l'ensemble des parties de l'ensemble E, is going to be the set of all the subsets of E. So the set, so we use this fancy letter P, and we basically write E. So it is going to be the set of all the subsets of E. So it is the set of these guys. So because A, B, C, and D are subsets of the set E, well, the set, this set P de E is going to be the set of all the subsets of the set E. Remember that all the elements or the members in this case are going to be sets. They are not individual numbers like 1, 2, and 3. No, these are sets. So another thing that you guys must have as a remark is that this set is not going to be empty. Well, this is actually known as the power set. So the power set is not going to be empty. Why is the power set empty? Because whenever we're talking about subsets, we have that the empty set is a subset of any set, and the set itself is also a subset of itself. So basically, it contains two trivial subsets. So the power set is going to have two trivial subsets. Just from the definition of a certain set, I mean, just from the idea that we are talking about subsets. All right. So the power set P de E is never empty. Is never empty. Why is it never empty? Well, it contains two trivial subsets. That is the empty set and the set itself, and E itself. All right. So there you have it, guys. That is your power set. Now let's have an example. One other thing that I can write here is that the cardinality of the set, of this set is going to be equal to 2 to the power n. Now, in this video, I'm not going to demonstrate that this is actually true. I'll actually do it in another video. So this is going to actually be a problem of a problem in combinatorics. So we're going to talk about a combination and all that, dénombrement, and all that good and fun stuff. So basically, we'll just admit the result. The cardinality of the set P de E is going to be 2 to the power n, where n is going to be the number of elements in what? Is going to be the number of elements in this set, that is. All right. So basically, here we have 1, 2, 3, 4 sets. So we're going to have 2 to the power 4, and basically that is your value. And let me just give you guys a very good example of what we've just of what has been laid as a foundation. So let E be the set. Let E, oh, that is not great. So let E be the set of all elements A, B, and C. All right. So basically, the power set of E is going to be the set of all the subsets of the set E. Now we have two trivial subsets, that is the empty set and the set E itself. All right. So the power set, first of all, let's calculate the cardinality of the power set of E. The power set of E, it is going to be 2 to the power n. Sorry. So in this case, we basically have 3 elements. So we have 2 to the power 3. So what is 2 to the power 3? Well, 2 to the power 3 is going to be 8. So basically, the power set of E is going to have 8 members. Now, all the 8 members are going to be sets. All right. The power set of E is going to be, so you first of all write your empty set, and then you write the singleton sets. So because we have 3 elements, we are going to have 3 singleton sets. So you have A, you have the singleton, B, le singleton, C, and then you also have, now you formulate sets with 2 elements. So you have A and B, and then you have B and C, and what is going to follow is the set. So it is going to be A and C, and then the set E, finally the set E itself is also a subset of itself. So we have that. So if you count these that I've written, you should find 8. You have 1, 2, 3, 4, 5, 6, 7, and 8. So the power set of E, of the set E of elements A, B, and C, is going to be the one listed below, and its cardinality is right on top. So thank you guys for watching, and I'll see you in the next video.